It'll be recorded and then put on YouTube. There we go. Cool. Alright. Is it going? Yeah, cool. Alright, so once again, just before we start, make sure you install Matter Control, which is this program right here on your computer, which you can get by going to robo3d.com. Today we're going to work on just kind of the basics of setting up and maintaining and then running a 3D printer, and then with whatever time we have left, we'll quickly go over some CAD and 3D modeling tips. So I'm Nathan Strich, for those of you who don't know. I am an independent contractor as well as teacher of 3D printing and 3D modeling with a mechanical focus, specifically revolving around robotics. That being said, I'm going to get started with showing you how to use Matter Control. So what you're going to do, first, clearly you have to hook up your 3D printer, which I already have, and make sure that it's connected. Then you'll go to settings and controls, and you want to start preheating everything as soon as possible. So this is the extruder temperature, and this is the bed temperature. The extruder is this guy right here, for everybody can see. That's what actually shoots out the plastic to be printed. And then the bed is this, which is where everything gets printed on. Now, while it's heating, just kind of want to get rid of all the... So you want to use 3D printing tape, which is very similar to painter's tape, but it's a bit different. It grabs, it lets the parts stay on the table a lot better. So, you can generally print on a 3D printer, a fresh new 3D printer, for the first few times after you've gotten it, but after that, you'll either start getting warping issues or just like not sticking issues whatsoever, which is why you use the tape. And in between rounds of tape, you do want to clear up all of the sticky stuff that's on there from the tape. I generally do this when the bed is heating, because then it dries really quickly. You can get most of everything. I'm going to show you just quickly how to do this. generally you want to do this nice and slow, seeing as you want to get printing pretty quickly. I'm going to do this a bit faster than usual. You definitely want to minimize all the bubbles and stuff that you get underneath it. And the bubbles you do get, you want to flatten out as much as possible. Anybody have any questions at this point in time?
Do you have to do a leveling?
So this, with the Robo 3D, it automatically auto-calibrates at the beginning of every print. So for Robo 3Ds, the answer is no. For some other printers, I know the answer is yes. Yeah, you'll see it actually does a 9-point calibration. So it'll correct for it in the coding. And then, so you want to get most of the bed covered in this, but you also don't want them overlapping. So what I generally do is I'll lay out the second one. Lay out the second piece of tape, flatten it all out, and then get a nice looking knife, and you just kind of cut along the edge of the lower tape. There we go. Because if you get it while it's because if it zeros on one of the places where it's overlapping, it'll cause a major issue sometimes in printing. It'll either run it into the table or cause warping. Warping is one of the biggest and easiest problems to have while printing. It happens all the time and can happen in various ways, from going like this, which is kind of drastic, but there's also things like this where it's just kind of like the corner came up a bit, where you can still technically use this part, except it just looks bad on the outside. So now that you're all taped up and ready to go, we'll find a part, which I did for you already. In this case, we're going to make a bottle opener. This is in Solidworks. So in order to do this, you do save as, and then you can't even see this on here. There it is.
You're changing the file type.
Hate it when I do that. It does happen. There we go. I save this to desktop for ease. Alright. Now, there's two ways to do this part. I find the easiest way is to just drag it over from whatever folder it's on, but you need to have an STL file. So it's on my desktop, dual screening right now, as usual. Oh. So I actually accidentally dropped that into one of the existing ones. So here, I dragged it into here, and now you can see we have a bottle opener on here. If you want to move it around, hit edit, and then you can drag it wherever you want. To get it in the center, just hit arrange. It's pretty safe generally to get it in the center. Sometimes you want stuff to be more towards the outside. Like if you're lazy and your tape's kind of beat up, but there's a good section of it that's still fine, you move it to the outside. Just be careful because that can also, because the bed's heat from the center, you can get a cooler area on the outside, which can very easily cause warp. So don't move it too far outside of the center, but it does work if you want to be lazy on occasion. So now we're going to run through all of the settings, which is the most important part. Actually, yeah. So, oh. Settings. So this stuff all means different things that will happen with your part. Your layer height in this settings, or in these settings, we're working on define settings. So 0.1 millimeters is your layer height. So for example, on here, like each one of those tiny lines is 0.1 millimeters thick. Your first layer height is how tall your first layer is. Generally, I keep this between 0.2 and 0.3. Layers. How many perimeters? 2 is generally fine. If you want it to be a little bit stronger, you can add more. Fill density. This is the important one. This is what will make or break your part. So I printed out a bunch of these guys from 0% up to 90% of infill, so you can see the difference. Try and keep them all together as I drop one on the floor. So you can make different settings work together. The two biggest ones are that you need to get to work together is fill density and top solid layers. If you have too low of a fill density and not enough surface layers, you're going to get a bunch of bubbles like this, because it doesn't have enough area to stick onto when it's printing. If you have too, and you can balance them out, so you can have more top layers for less fill density, or more fill density for less top layers. I generally go anywhere above 0.3, which is 30% infill, with 4 to 5 top layers. So we're going to go with 0.4 in this case and do 0.35. Avoid crossing perimeters, don't care about that right now. External perimeters, doesn't matter again. Really depends on your what you're trying to do. For this, bottom solid layers, 3 is fine. Infill, as I said, this anytime you hit this, you will permanently change all of them, and you have to go into this menu again to change them. But you can change a lot of the things like fill density all at the same time. Oh wow. For all of these are the different speeds. My recommendation, change pretty much everything to 30. Except for travel. Travel can be like 80. And for this, we're just going to do 30. Make sure you save after you change anything. Skirt, touching. So the skirt it does a couple of loops around to try and get some of the filament going before it actually works on the part. The issue is when you're doing something that needs support, like these, and it still doesn't start when it's supposed to start printing, the entire print will fail. Because if that first layer of support doesn't print, it won't work at all. So there's 2 ways to get around that, which is adding a raft, which is this. But in certain cases, like when you're doing something like this, you don't want a raft because you want people to see what's through the other side without spending 3 hours to barely scratch the surface. It was probably actually more like an hour and a half, but still, like that's all I got off in an hour and a half. So rafts are a pain to deal with, but they do help you get better prints. But I generally leave raft off because I figured out a trick recently, which I'll show you in a minute. Touching is fine here. Support material, don't need it for this. But generally you want it either grid or lines. 5mm is pretty good spacing, where it's actually close enough to keep it all level, but not too far away but not too close where you'll end up destroying the part when you're getting rid of your support. If you have a dual extruder, I highly recommend getting the water-soluble filament for support material, but this is only a single extruder, so you can't do that. Repair, just generally connect bad edges and close polygons. For this, we'll just hit center on bed, and then, as I said, you want to hit preheat at the beginning of this. Before you start any of this, you want to hit preheat so that when you finally get through all of your settings, you can just hit go.
How long does it take to preheat?
Depends on where it's starting at and your room temperature. This generally doesn't take anything more than 5 minutes. So right now, I raised the Z-axis up a bunch so that I could easily get the tape on there. And now it's going to do its auto leveling, so it's going to hit 9 points on here. And I'm also going to show you my quick fancy trick to deal with the not printing right away problem. So even that small piece is going to take about an hour to print. That's because it's on high quality settings. Because who doesn't want a high quality bottle opener? Alright, and here's where the trick comes in, is you just kind of spin the filament feeder until it starts feeding, and then you'll see it actually starts right away. But it took me a couple of weeks to figure that one out. It's loose until right before it starts heading over, and so if you get it to if you spin it to spit out a little bit of filament right before it goes to start, you'll have the filament right at the bottom of the extruder, which is the issue which happens because gravity plus liquid, it's gonna fall out. So over time it'll just kind of leak out a little bit, and you won't even notice it like dropping, because it won't. It'll just kind of stick to the nozzle. But that means that there's probably about 1 millimeter or 2 of material that's not right up there at the bottom. And that's probably the most important thing that I figured out over the past 2 weeks of working with this. 3D printers, I've worked with a bunch of different ones, and every single one has its own unique quirks. Some of them, you really need to have, they don't come with it, but you need to have an enclosed space. So, I've worked with the Finias before, and for that we just put storage tubs over them while they were printing, which kept all of the heat in so that it wouldn't warp. And because the beds were bad at heating. And Cubex printers, you have to reset, or any printer with cartridges, you just reset them so it thinks that you're still printing, and then you get another roll and feed it in from outside. I personally do not like cartridge printers. I think it's silly because it limits you. And the whole point of 3D printing is to be able to make things quickly, just to have fun with your mind and make stuff. I use it for mechanical design. I'll print gears and stuff just to make sure that everything fits properly. I've made drone legs. I've made mounts for Kinects. I've been working on this for like a week and a half. It's a business card holder with my name on it. And anything you want to imagine in 3D space, you can, if you spend the time, make it actually appear, like using 3D printing. And that's what's so cool about it. And from a mechanical design perspective, or just a business perspective in general, it's really nice that you can very, very quickly and easily move from design to design. Just even if it's just like a change of one hole size, in a matter of a few hours, you can have that next iteration done, and make sure that that's all that was wrong with it, and then move on to the next one. When I first got hired by SkySense at the Robotics Accelerator at Qualcomm, I was designing drone legs for them, and for the Iris Plus drone. And so they kind of have this track on them, and so the first one I designed was meant so that it could slide onto the track. When we actually finally got the drone, we realized that was not possible. So I then just redesigned it to fit in the different slot where the legs already were, which ended up working out just fine. But it took a good long while. It took about 4 or 5 iterations to get everything dialed in right. And that's why I suggest, um, you know, well, yes, you can go to the San Diego Library, and I do definitely support anybody who goes there to do 3D printing, because they have free 3D printers for public use there. If you're really interested in it, get one, or make sure you have access to it pretty often, because one small thing will be like, now I really need to reprint this, and if you don't have access to it, you're gonna really want it. That's why there's so many different versions of this, because of failed or I didn't like it attempts. What else? Yeah. Oh, so the next big thing is, forgot to show you like the coolest part of this. You can actually watch it print and see what the printer is telling it to do at any given time. Once it syncs. Alright, anyways, generally, I think it's just because it's too dark and unfocused. But generally you can see it'll print out lines on here, and then moments later it'll do it on the actual machine. So it's showing what instructions it's sending to the machine, which is pretty cool to watch. Sometimes I have a lot more fun watching that than I do watching the machine. I don't know why. Maybe it's just because I'm a nerd. And then
You have to leave your laptop connected to it the whole time that it's printed.
but there's a few different ways to get around that. Use an old laptop is one of them, or desktop for that matter. But yeah, my laptop's locked up for the next, well, not locked up, but I can't move it for the next 40 minutes or so. 40 to 50 minutes. So the next thing I wanted to show you guys was these two websites. Cab and Thingiverse. You can find a lot of different things on these websites. If you're looking for like just kind of cool gadgets and stuff, I suggest going to Thingiverse. If you're looking for actual usable models that you can edit yourself, go to GrabCAD. GrabCAD, you can actually search by what CAD program you have. So, say I want to find a GoPro. Oh, nope. There we go. A GoPro mount. Did you grab yours, Hansel? Okay, cool. And mind you, this is something I actually did. And then you can go here to advanced search, go software, and Solidworks is all the way down there. Search. I believe. It was this one. This is the one I downloaded to make consoles. And since they had a Solidworks file of this, I was able to edit the part and make it work for what I wanted it to. So rather than printing this as two different parts and making this bottom part out of aluminum, I decided that's silly. let's just make it out of one part and put threads in the 3D printed parts. And here, let me grab it. Coolest part about this is that with no like metal assistance or anything, you can thread this into any tripod or regular, mount for a 1/4 volt. So with pretty much any, anything you would want to mount this onto, you can, and that's without having to make a metal part like that person did. Which is what I love about GrabCAD, is that they give me files native to programs rather than STLs. STLs are a pain to work with, that's an understatement. They're awful. Solidworks, the best you can do with them is import them, and that's if Solidworks will let you import it. It really depends on the model. But from there, basically what I do is I just get dimensions from it and then build it again on my own. So if you're trying to make something and you want to make changes to it, don't get just the STL, or know that it's just the STL and you're going to have to model it yourself anyways, if there's no other option. So GoPro, or for GrabCAD, it's better for actual parts, and then Thingiverse, there's just all sorts of cool stuff. Sometimes you can find real and actual cool parts, like this is a shaft coupling. At least I think that's cool. That you can 3D print. But you can find things that, this looks like a GoPro mount for a drone. This is like a little Goku, I think.
Sure.
There's a comb, a castle. You print Legos. There's all sorts of stuff you can do with this, which is what's so cool about 3D printing. As I said, you make some art for your wall. A map for your watch that broke. Or you can print individual links for a watch band. I think basically what I'm just trying to say is that 3D printing has a lot of possibilities of what you can do with it. Any questions?
Yeah. So what are limitations of different types of printers?
Okay, that's actually a very good question. So, filament printers, like this one, generally do not have as high of a resolution as the resin printers or powder printers. Resin printers generally use DLP laser projector to basically form it by shooting images up at it. You'll still get small little grains for resolution, but it'll be a lot smaller than, say,
Are
1
those
millimeter.
common, like DLP and
Yes.
powder,
The-
for like
so-
personal
so
home use? Because
for
that's the
home
only
use,
kind I've ever seen.
Not really.
Yeah.
They're starting to get a bit cheaper. So if you want to do that, I still want to buy one of these too. I'll show you one. I think is super cool. I would love to get one of these. It's really cool because it's okay. So it's SLA is the type of printer that this is. But what's so cool about it is you can make your own print space. All you get is this. And this has a little laser here, and then you assemble it yourself, and then make a tub for your resin, so you can make it any size you want, and then have it build it up. I think that's super cool.
How expensive is the resin compared to?
Resin is a lot more expensive. It's about between $60 and $100 per liter, versus that roll of black filament, which is a kilogram, was what, $25 at Fry's.
It's a bit expensive.
So SLA is more expensive, but it's starting to come down in price because of things like this. The least expensive one other than this that I know is probably around $1,000. This is $100.
What could we hypothetically not print on one of these that we would be able to print on one of those, an actual part that you could think of that you would say, oh, I wanted to have printed this, but I couldn't because...
It would just be smaller objects. They have a higher resolution, as well as some things with support. It's a lot easier to do this without support, because what it does is it prints it and pulls it out of a bath of liquid. So it's actually printing it upside down.
Mm.
Any other questions? The other cool thing, another reason why I don't really like cartridge printers is it very much limits you on what kind of filaments you can use. If you look around, you can find flexible filaments, you can find polycarbonate filaments, and all of those things you can, if you wanted to, you could do it on here. You just have to upgrade the extruder. Once you have a 3D printer, it's a lot easier to make your 3D printer better. And there's a lot of different things that you can do for that. You can add heating upgrades, which means you can do higher temperature materials. You can do you can add a second extruder so that you can do water soluble support, or do multiple colors in a part, or print multiple parts at the same time. There's all sorts of benefits to just having one in the first place, and then once you have it, it's a lot easier to just make it better.
Going along with that, is there any printer that you would recommend? I would assume that they're not all so modular. What would you recommend for a base that you could build off of very easily?
So I'd say wait a couple of months on getting the next revision of this. The R1 Plus is very good. I've been dealing with that at work, or at one of my jobs. This is one of my other jobs, and I'm printing this here, or using this here. The R1 Plus is very good. I like it a lot. This one still has a few quirks. That one gets rid of most of those quirks. And then, other than that,
Here's one I just got a couple weeks ago.
The
I got it in Kickstarter, M3.
M3D. I've heard good things about those.
I think
as
it's like
well.
maybe $350 now.
Yeah, I'm waiting.
Now you don't have to wait 6 months or 8 months.
Yeah, I'm waiting for two different printers from Kickstarter right now. The Genesis Duo, which is a foot cubic print space, That's a dual extruder, which I'm super excited for because that's so much space to play around with. And then I'm also excited for the Tico, which is a Delta printer. Delta printers are usually a little bit cheaper, but you have to be careful because they generally don't have as big of a print space. And while yes, their print resolution can be higher, sometimes there's just other things that get off. Because if it's not calibrated correctly, your z-axis may be perfect, but once you go a little bit more in one direction than the other, it'll be a lot more drastic, which is why XYZ printers for filament printers is what most of them are. Because if you're not, you have to be certain that your all three of your arms are going to be working properly.
So the Delta printer is that, I'm looking at it now, is that the common kind where there's like 3 arms?
It's like, yeah. This is the one that I ordered off of Kickstarter. Should be getting both of them around December. So yeah, that's a Delta printer. They actually optimized this one so that it can actually print on the outskirts, but most Delta printers only have a circular space in the middle. I don't know why most don't optimize it, but that's the way it is. Any other questions?
What do you think about the UI for this printer compared to other ones you work with? Are there any features you wish they had that aren't there, or perks?
Except for the when it prints support, it failed to print like the first couple of lines, which will ruin a print. After I learned that trick, this is one of the better UIs that I've had to deal with. Matter control has been very easy to use and utilize. Oh, now you can see it kind of moving around up there. But for me, I like being able to have a lot of different options. Some people that's not as good. When I was troubleshooting that issue, I got it to work a different way, but it only worked sometimes because I actually went and edited the G code here, which is not something I recommend doing for any beginner. If you know how to use the CNC, it's pretty similar, but other than that, don't touch the G code. It's a bad idea. But basically, what I was telling it to do was just to go across once and print 10 millimeters of filament during that. Which, when it worked well. But when it didn't work, it would just shoot out like 100 millimeters backwards, which made no sense to me, but okay. Which is why I just got rid of it and learned how to just spin it. Works more consistently. Every printer you use will have some sort of set of quirks. It's just figuring out how to accommodate for that as quickly as you can. I would say I'm probably there now after working with this for 2.5 weeks.
Work with any powder printers?
I actually have not. I've gotten some stuff printed from powder printers, and they've been very good. Once again, it's very similar to SLA in that you can still see very little bits of layers, but as a whole, they're do come out a lot nicer. That's how most metal printers work nowadays. Although they're starting to come out with some that are basically MIG welders and will print like one of these filament machines, except with metal, which is pretty cool.
And I saw this thing with the 3D printing of the metal bridge over
Yeah.
now.
Yeah, so there's one company that did that, and then a different company actually made like a stationary not tabletop, but like big box to do 3D printing with the same method of MIG welding. So you can do steel, stainless steel, aluminum, a lot of different types of metals by doing it like that. You can even do titanium. It's going to be really expensive, but you can do it.
I heard there was one that was going to have like carbon fibers that can go through carbon fiber plastic.
I did not really hear about that. There is carbon fiber mixed filaments. So I'll show you one last thing. I think. So, let's see. So here's a bunch of different types of filament. Like this is brass filament, copper filament. Mind you, this is mixed filament. This isn't pure. So if it's probably, I believe it's like 40-60. So you'll have little bits of copper in there with a bunch of PLA or ABS. And then, yeah, this stuff is carbon fiber infused. So, you know, and your print temperature will be different for each one of these. Because if the material that you're printing with changes, the temperature you have to extrude it at will change. And you'll have to figure that out for yourself. Your feed rate of filament will also probably change. Let's see. This stuff is magnetic, which is pretty cool again. There's some now that have glass infused, and there's like glow in the dark, but as well. But a lot of it depends on the ratio. But some of the filaments that have stuff mixed in will actually make it a lot stronger. So if you use the brass or copper, it'll be a lot stronger. It'll also be a lot heavier which is why the glass filament is becoming a big thing right now, because of how light it is compared to the other ones, with how much strength it gives. And it doesn't change the print temp that much. It's got about another 10 minutes or so. If anybody has any more questions, if not, that's pretty close to it. I don't think there's enough time to do anything meaningful with teaching CAD right now. If you want to do another week where I do CAD, that's fine. But yeah, this is 3D printing by somebody who actually uses it for their job, rather than a salesperson. Yeah.
Can you go over the format types for? So you said that you didn't like the
So the
STI or whatever.
STL. STLs is what you have to use for 3D printing because it's universal amongst every program. Solidworks is my favorite CAD program to use, which is what I showed you this on originally. This is SolidWorks. Mind you, I know like 12 different CAD programs or something like that. But being able to work on a part is very important because maybe I want to add a hole in here so I can put it on a keychain. Something as small as that. If you have an STL, it's going to be impossible to do that in the initial file. You're going to have to redesign it. Like, even if you want the same exact thing, you're going to have to redesign it and then make it with the hole.
What does it do?
So STL is just getting the surfaces. It's the surfaces in a bunch of different triangles. SolidWorks files actually get the full solid and all of the different steps it takes, like over here, to be able to get there. So this extrude probably got most of this out here, and then this fillet right here probably did this. And I can tell that just because I have a lot of experience with CAD. That being said, if you haven't had a lot of work with CAD and you don't really know how to edit it, then just picking stuff up off of GrabCAD or Thingiverse is fine. And you don't really have to just know that you can't really change it that much. Any other questions? Well, I hope you guys enjoyed learning a bit about 3D printing and how to do it right.
Seems to have a learning curve
Oh.
associated with it.
And every 3D printer has a learning curve, and every learning curve is different. And sometimes they're like, oh, it's nice and easy and don't have to worry about it. And then like 3 days later, it just hits the fan. Like this morning, I came in from printing stuff last night, and this part broke. This holds the belt for the y-axis. So, mind you, I didn't even look at any instructions. I opened it up because I could tell that the y-axis was moving a lot looser than normal. So I figured that was wrong. Lifted up the bed, went underneath. Luckily, one of these came as an extra in the parts that came with it. Replaced it, started working again. It's the small things like this that really can make a big impact on whether your machine works or not.
How much was this machine?
I believe it's 700. Yeah. Oh, 800. There we go. Which is why I'm still happy that I ordered my printers off of Kickstarter, because with $200 of upgrades on one of them, still paid only $700.
So is this the original one that they produced through their Kickstarter?
What?
This one right
Yeah,
here?
this is, it's a little bit different. They made a couple of changes along the production line, but as a whole, yes, it's the same one. But the R1 Plus, which I've worked with, which is not yet out, I have had like 2 failed prints rather than like 20 failed prints. So, and that's over a longer period of time. I'm a fan of that one. Other than that, I've heard good things about RepRap printers and what's the other one? I'm trying to think. There's one more that I can't think of right now. Don't get the most recent MakerBot. That one was a disaster. If you get one of the older versions, it's fine. But they really ruined their reputation with the most recent one. PrinterBot, which I think I already said. But that's the other one that I've heard really good things about.
Why do you think that there are so many different 3D printer companies out there? It would feel like, I mean, are they really making improvements on one another, or are they just doing the basics better?
It's a little bit of both. It's trying to be competitive while claiming something they've done better. You know, we've got a 3D scanner in ours. We've got a heated bed, or right off the bat, you can print like straight out of the box. Assembly. It's cheaper, but you can assemble it. Like, it's realistically, most of them are very similar. It's more the software that matters once you get the hardware down. I'll say that for most of this stuff. The 2 things that really matter, like the stepper motors, as long as they're all pretty much the same, it's fine. The heating elements in the bed and the extruder are the most important hardware parts. And the cooling on the extruder. Because if you don't have good heat sinks on there, it's going to jam up very easily.
Do you know of any dual extruder 3D printers that are relatively inexpensive?
One I ordered.
Which one?
But, well, you're going to have to wait for a while.
Is it the Genesis? Or?
Yeah, the Genesis Duo. Well, although it's no longer called Genesis. It's just the Duo. So this is the Genesis, or the Duo. You can see effective for 300, but then bought $200 of upgrades for it. So I bought the heated bed and 2 heating upgrades. So if I wanted to, I could do dual extrusion of different colors of polycarbonate. So why not?
What's different about this?
What's different about this?
Mm-hmm.
I would say it's constructed different than most, and the biggest difference is the print space, and the cost for it. I don't know of another printer, let alone a dual extruder printer, that you can buy for $300. And it's got a foot cubic print space. This thing has, it's like 8 by 6 by 6 or something like that? Or it's 8 by 8 by 6. Most 3D printers don't have anything bigger than that. That's a pretty standard size. Which is why I went for that. is because it was such a big print size, a dual extruder, and it didn't cost that much money. It's worth the wait, although I'm still angry because they made the wait longer as of last week. They're like, it's going to be ready by the end of next month, and then they're like, nope, December. But that's Kickstarter for you, so it happens. Alright. I hope you guys enjoyed the class or lesson.